The Andromeda Mystery: How a Cosmic Puzzle is Challenging Our Understanding of the Universe. When we gaze up at the night sky from a dark location, away from the glare of city lights, we might catch a glimpse of a faint, hazy patch of light. That smudge, barely visible to the naked eye, is none other than the Andromeda Galaxy, also known as M31, the closest spiral galaxy to our own Milky Way. Though it lies an astonishing 2.5 million light-years away, in cosmic terms, that's practically in our backyard. So close, in fact, that the dark matter halos of Andromeda and the Milky Way are believed to be touching. But recently, Andromeda has become the center of a growing scientific enigma, one that not only baffles astronomers, but could potentially shake the foundations of modern cosmological theory. A peculiar and seemingly inexplicable arrangement of dwarf galaxies orbiting Andromeda has been discovered, one that appears to defy the expectations set by the standard model of cosmology. A galaxy not so different from our own. Before we dive into the cosmic mystery, it's important to understand Andromeda's broader context. Structurally, Andromeda shares many similarities with the Milky Way. Both galaxies are massive spiral systems with billions of stars, surrounded by swarms of smaller dwarf galaxies. These dwarfs are considered the remnants of earlier galactic mergers, fragments of smaller galaxies that were captured by the gravity of the larger host. According to widely accepted models, such satellite galaxies should orbit their primary galaxies in random orientations, influenced by the chaotic, hierarchical nature of galactic formation and evolution. They are expected to form a somewhat isotropic distribution, a spread that's roughly even across all directions. But in the case of Andromeda, that's simply not what astronomers are seeing. A one-sided cosmic oddity. A recent study led by Osuki Jamie Kanehisa of the Leibniz Institute for Astrophysics in Potsdam has confirmed a phenomenon that is as puzzling as it is fascinating. Nearly all of Andromeda's known dwarf galaxies are located on just one side of the galaxy. Out of 37 satellite galaxies examined in a new and more precise dataset, all but one lie within a 107-degree cone, a wedge of space comprising only 64% of the total orbital area around Andromeda. Even more intriguingly, half of these satellites orbit within a flat plane, akin to the way planets orbit the Sun in a relatively flat disk. This highly skewed, planar arrangement of satellite galaxies is rare. So rare, in fact, that researchers cannot reproduce it in most simulations of galaxy formation. The oddity lies not only in the asymmetry, but also in the structured nature of the satellite plane, both of which contradict fundamental predictions made by current cosmological models, including the lambda cold dark matter, lambda CDM, model. A challenge to cosmology. In their efforts to test the anomaly, Kanehisa's team analyzed over 300 simulated galaxy systems that are similar to the Milky Way-Andromeda pair using high-resolution cosmological simulations. Yet only 1 out of 300 showed a satellite distribution that mirrored Andromeda's extreme asymmetry. This means such arrangements occur in less than 0.3% of cases, marking Andromeda as a significant cosmic outlier. According to co-author Marcel Pawlowski, the study's results indicate that Andromeda's satellite configuration is not only rare, but nearly impossible to replicate using known galactic formation mechanisms. The researchers concluded, "Our analyses show that such a pattern is extremely rare in current cosmological simulations." This raises an alarming question. Is Andromeda truly unique, or is our entire model of small-scale galaxy formation in need of revision? Possible explanations and dead ends. So what could possibly cause such a bizarre, one-sided configuration? One hypothesis is that Andromeda absorbed a group of dwarf galaxies all at once, perhaps from a previously bound cluster, sometime in the recent cosmic past. This kind of event could explain the asymmetric alignment. However, such an acquisition would still be rare and does not fully account for the thin, orbital plane many of these satellites share. Another possibility involves the Milky Way itself. Given the relatively close proximity between Andromeda and the Milky Way, so close that their gravitational fields may already be interacting, perhaps our own galaxy is subtly influencing the orbits of Andromeda's satellites. Those simulations have accounted for the Milky Way's gravitational effect. It's possible that unknown dynamics are still at play. Ultimately, however, scientists are left with a sobering conclusion. There is currently no accepted explanation for this peculiar asymmetry. At present, no known formation mechanism can explain the collective asymmetry of the Andromeda system, the team admits. The emphasis, however, remains on at present. Hashtag a new galactic puzzle, Andromeda 35. As astronomers ponder the large-scale mystery of Andromeda satellites, a smaller but equally baffling discovery has also emerged. Andromeda 35 the faintest and smallest known dwarf galaxy orbiting Andromeda. Detected by the Pan-Andromeda Archaeological Survey and confirmed via follow-up observations with the Hubble Space Telescope, Andromeda 35 has a stellar mass just 15 millionths that of Andromeda. It is remarkably dim and tiny, comparable to the ultra-faint dwarfs of the Milky Way. But Andromeda 35 holds another surprise. Unlike similar dwarfs in the Milky Way, which have not formed stars for the last 10 billion years, Andromeda 35 was still forming stars as recently as 6 billion years ago. This is unexpected because the reionization era, a period when the universe was filled with energetic light from the first stars and black holes, should have heated and expelled the gas from tiny galaxies like Andromeda 35, halting star formation. Yet, this galaxy held on to its star-forming material far longer than expected. This suggests that either Andromeda 35 has unusual properties, or our models of galactic gas loss and cooling in small galaxies are missing key components. Hashtag will the Milky Way and Andromeda still collide? You've probably heard the dramatic prediction. In around 4 billion years, the Milky Way and Andromeda are expected to collide and merge into a massive elliptical galaxy, nicknamed Milkdromeda. This cosmic merger has been widely accepted and depicted in stunning simulations and artistic renderings. However, new modeling by Tilsala and his team at the University of Helsinki suggests the outcome may not be so clear-cut. Taking into account updated mass estimates and the gravitational influence of other local group members, like the Triangulum Galaxy M33 and the Large Magellanic Cloud LMC, the future collision is less certain. According to the new simulations, when factoring in the trajectories of all 4 major bodies, Milky Way, Andromeda, LMC, and M33, the probability of a direct Milky Way-Andromeda collision drops to just over 50%. The LMC, which is moving perpendicular to the Milky Way-Andromeda line of motion, might even deflect our galaxy and prevent the anticipated cosmic crash. So, while Milkdromeda remains a possible future reality, it's not guaranteed. We may instead see our galaxies narrowly miss each other, entering into a slow gravitational dance that could last for eons without merging. Hashtag a universe of unanswered questions. From the one-sided arrangement of dwarf galaxies to the star-forming oddities of ultra-faint satellites, the Andromeda Galaxy is proving to be a hotbed of cosmic mysteries. These puzzles remind us that even in our own galactic neighborhood, there is much we do not yet understand. Astronomers are now eagerly awaiting data from new observatories like the Euclid Space Telescope, which is already scanning the cosmos for dark matter and galaxy structures, and the Nancy Grace Roman Space Telescope, which will help us probe the early universe in unprecedented detail. Meanwhile, the James Webb Space Telescope JWST continues to provide critical insights into star formation in both the ancient and local universe. Andromeda may one day collide with us, or it may drift past. But one thing is certain: its secrets will keep astronomers busy for generations to come.